All right. The only other thing I need to mention, your test is going to be a week from Monday. It's going to be all over vectors, anything we've talked about up to that point. So it's not too early to start going back and looking. How was the quiz? It was okay? Okay. All right, well, we'll see. I haven't put it up yet. In fact, I'll go ahead and do so right now. That was second, so it was right there. So, I mean, okay. Could be worse, so I'm happy. So we'll see how you guys did. I'm not going to say it on the recording. But the test is coming up on the 4th, a week from Monday. Remember, these happy minutes, you can retake them, but it's within 1 week of when it's given. Like this past Monday is the 18th. You have till this Monday morning at 8:05. Okay, Tuesday by 8:05. So this one today, you have until Friday of next week by 8:05. Okay, and the same thing will be for this quiz that we just took because we took it on a Friday instead of a Thursday. Okay, well, let's see. What are we talking about today? The dot product of two vectors. The dot product is an important vector operation in multivariable calculus. So for those of you planning to move ahead in mathematics, this is definitely a concept that you will see again. When adding vectors, we get another vector. However, when multiplying vectors, we get a scalar. Remember, that's a measurable value. Think of the dot product, also called the scalar product, as directional multiplication. The dot product is related to the angle between the two vectors u and v. Now, if a vector is growth in a direction, then the operations we can perform are, and we've already seen the first two in the previous lesson, adding vectors to accumulate the growth contained in several vectors, 2, multiplying by a constant, which we call a scalar, to make an existing vector stronger, and 3, this is the new concept, dot product, which applies the directional growth of one vector to another. The result is how much stronger we have made the original vector, positive, negative, or 0. So the dot product is just the mathematical term we use to say we're multiplying vectors. Okay, so how do we do that? Well, we've become accustomed to component form, given that A is the horizontal and B is the vertical, right? So what you do when you multiply vectors, you multiply the horizontal components, the A's, you multiply the vertical components, the B's, and then you add the products. Okay, that's how you multiply vectors. When you multiply two vectors, you just get a single number, a scalar. Okay, and then we've got some properties that we're going to be seeing throughout the lesson. Couple of which I'll go ahead and mention. If you multiply a vector by the 0 vector, you do get 0. Vector v times vector w equals vector w times vector v. What do we call it when we can reverse the multiplication? What property is that? Commutative, there we go. Okay. We've got a couple of properties here on distribution, but probably the one that I definitely want to go ahead and mention is this one down here, now that we know what a dot product is. What do these bars mean? Remember, that's the magnitude, the square root of a squared plus b squared. So if we were to square the magnitude, we're saying that's the same as taking a vector times itself. Okay, vector times a vector, and I'll be showing you that today in our last problem. Okay, well, let's get a few of these done. So I've got 3 vectors, u, v, and w. We've got the component forms here, a and b for each. So the first thing, u dot v. So I want to multiply u, 3, 4, times v, which is a negative 1, 5. Okay. Well, based on the definition that we were just talking about, how do I do this? How will I multiply vectors? Take the a's and the b's. Okay. So I'm going to multiply 3 times the negative 1. We're going to multiply the corresponding values. And then what do I do with that? What was the operation? We add them. So now I'm going to multiply 4 times 5, the vertical components. Okay. So let's see here. 3 times negative 1, we're looking at negative 3, plus 4 times 5, 20, which will give me 17. There you go. That is all you have to do to multiply vectors. That's what we refer to as a dot product. Okay. Any questions? Okay. Multiply the corresponding values, add those products. Okay, now B is an extension of A. You'll notice we've already got the dot product for U and V. So now I want to take that, the 17, and multiply it by W. So 17 times W, which is 4, negative 3. Well, how do I do this?
Would you just distribute?
Yeah, just distribute. So I'm going to multiply 17 by both 4 and negative 3. So 17 times 4, 68. 1768. I'm getting closer. One of these days it's actually going to work, and it's going to be really cool when it does. Okay. Okay, 17 times negative 3. I know, we've had the discussion. Okay. Negative 51. There we go. All right. But these first two examples are also designed to show you, again, the idea, if you multiply two vectors, you get a scalar. It's just a number. But if you multiply a scalar, a number times a vector, it remains a vector. Okay. All right. Well, let's try C. The dot product of U and 3V. So U, component form of 3, 4, times 3V. So 3 times negative 1, 5. Okay. So what would you actually want me to do first? Yeah, I'd probably go ahead and take care of the 3, distribute him. So the 3, 4. Okay, dot, let's see, that would be negative 3 and 15. Okay. And how do I multiply vectors again? I keep forgetting. A times A. Okay. So 3 times negative 3. Okay. 4 times 15. We multiply the horizontal components, we multiply the vertical components, and then we take the sum of those products. So let's see, that's a negative 9 plus what? 60. So this is 51. There we go. Question. Is anybody having a hard time? Okay. All right, and now our last one here, the magnitude squared. So without the square, we become accustomed to seeing the magnitude is just the square root of a squared plus b squared, right? So if I were to square that, the square root and the square, remember, what do we call those mathematically? Starts with the I. They're inverses of each other, okay? So they're going to cancel each other out. So really, it's just a squared plus b squared. Well, if you take a look, oh, what was W? It was 4 negative 3. So 4 negative 3 times 4 negative 3. We'll go ahead and run with the definition that we've been using to multiply these. If I multiply the horizontal components, 4 times 4, well, that's just a squared, right? Plus, multiply the vertical components, negative 3 times negative 3, well, there's your b squared. Okay. So what am I actually looking at here? 25, 16 plus 9. That's it. Anybody having a hard time not seeing where any of these values are coming from? Okay. Questions? All right, well, that is as far as I wanted to go. I wanted to at least give an introduction. So Monday when we come in, we'll have our next round of Happy Minutes, and we'll go ahead and start talking about the angle between two vectors. Okay, good. Well, let's go ahead and get those calculators back up to the front. You can grab your phones.